So what's inside, Randy? What's it all about?
Yeah, so this is the octoScope test bed. We've got two anechoic chambers stacked on top of each other. And in this particular case, we've got a couple Wi-Fi devices, one in each chamber, communicating to each other, under which we're running some tests. So here you see a Netgear R7000 as a sample device that we're using.
Right.
The blue material is an absorptive foam that provides the anechoic capability of the chamber, dramatically reduces reflections, and improves greatly the repeatability of the testing that we do in this chamber. You know, traditionally, people would use a shielded enclosure or do open air tests, and the challenge with a shielded enclosure, simple shielded enclosures, there's a lot of reflections inside, and you don't get repeatability of over-the-air tests.
Right.
So in this case, we're radiating to the device. The anechoic foam provides for chamber repeatability, and so you can run the same test over and over again and get identical results very quickly. On the outside, connecting the two chambers together, we've got a variable attenuator, what we call our quad atten. There's 4 different electrically controlled attenuators that allow us to adjust effectively the range of the two devices that are being tested, effectively how far they are from each other.
Right.
And so we can emulate motion and variable range with that, with the quad atten. We also have a interference generator stacked on the outside. So there's the quad atten in the back and the iGen out front. And the interference generator simulates both narrowband interference as well as the generation of Wi-Fi traffic. So it can simulate things like radar pulses from traffic radar, it can simulate Zigbee, microwave ovens, simulate baby monitors. That's sort of a narrowband interference. It can also simulate Wi-Fi traffic and fully observe the Wi-Fi protocols, but insert a great amount of traffic to load down the channel and see the performance of the devices under channel loading.
Right. So you mentioned that you aren't really actually doing full EMC testing, right? That's a whole separate ball of wax, right? So what exactly are you testing for here? What are you enabling the testing of? So
in many cases, people are trying to get a rough estimate of what the antenna pattern is, and are there any blind spots in the access point in terms of its antenna shape. Also, there's a tremendous need for software regression testing and behavioral testing. So as we start to look at things like fast roaming and handoff between access points, or we look at the movement of devices or the variable loading of channels and the need for an access point to dynamically adapt to different channels, all that can be all of those behaviors can be tested within this chamber.
What are some of the major trends you're seeing in wireless right now?
So we see there's really some big challenges around coexistence and adaptation. So one of the big trends we see is the proliferation of IoT devices.
Right.
So we see technologies such as Zigbee and Thread and WeSun and of course Wi-Fi. And there are many groups pushing forward technologies for in-home and out-of-home IoT devices. And very often these are using unlicensed bands that have to coexist in the same frequency spectrum. So it's a big challenge to assure that down the road, when there's not a few devices in home, but many hundreds of devices in home, that these will all coexist nicely, and you won't have just a congestive collapse because of all of the devices trying to hog the same channel.
Those are all valid issues, Randy, but is there anything else happening on the horizon that's maybe causing more angst for engineers?
Yeah, sure. So, on top of the IoT devices just mentioned, we also have LTE unlicensed and LAA being considered as a technology to use the unlicensed bands.
Right.
And those technologies in concept will bond 20 megahertz data carriers in the unlicensed band to the operator's existing spectrum in the licensed band. And the big question is coexistence. How do those devices behave in the presence of Wi-Fi, and how does Wi-Fi behave in the presence of those LTE unlicensed signals?
Right. But I think we've been doing that for some time as well. So do you think the operators are not being as careful about what they should be doing?
No, I wouldn't say that. We're at the early point of it, and the results to date have been mixed.
Yeah.
But it is early. both communities are working very closely to solve those problems, but there are a wide variety of devices, both on the LTE side and on the Wi-Fi side.
Right.
And many of these adaptation algorithms and sensing algorithms are proprietary in nature. So there is an awful lot of testing that has to happen, and it's something all the engineers should be concerned with. You know, how do you create test coexistence, and how do you do that in a repeatable fashion?
I guess
got a pretty good offer here.
Talk to octoScope about that, I guess, right?
I hope so.
Good job. Thanks, Randy. Appreciate it. Okay.